Right. Welcome back for the next session. We were discussing laws of manufacturing in the previous one, and the main concept which we concluded the session with was the economies of scale, right? So I'll continue my discussion, and I may emphasize now economies of scope, right? So this paper is one of the initial papers. You can say economies of scope by Panzer and Willig, right? And the main idea here is if I have two products, total quantity for product 1 is X1 and for product 2 is X2. The total cost of producing X1, X2 is actually lower than if I just produce X1 or I just produce X2. And we actually call this total cost function as sub-additive, right? So if you recall, when we talked about the economies of scale, we were saying that the average cost is decreasing. In this case, the total cost of jointly producing X1 and X2 is actually lower than the individual production, right? So the total cost function is sub-additive. And if you just rearrange this, it will look like this, right? So going from 0 to 2 is actually the cost is higher than if you go from 1 to 2, right? And the main idea here is that the firms grow on the back of one successful product. And this concept may be not very trivial to understand, but one reason which can lead to economies of scope could be because customers may have varied demand. They may, so if you produce multiple products with different variety, in that case, the customer matching may be better. You may have a higher demand. So demand aggregation, this also leads to higher volumes, which allows you to have higher utilization of your capacity, right? Now, can the technology of additive manufacturing can come to our rescue and can actually improve the economies of scope, right? So I think that is something which may be relevant in the future, how additive manufacturing can enhance economies of scope. Right. So the other concept which becomes relevant is what we call as economies of complementarities, right? So it may happen that so this paper again is by Milgrom and Roberts, published in American Economic Review. It's a slightly dated paper published in 1990. And the main idea here is so when we talk about manufacturing, the manufacturing cannot be seen in isolation, right? So we have marketing, we have design, we have manufacturing, engineering, organization, right? So all these things work in sync with each other, in tandem with each other. And utility of flexible machinery increases with the use. So this example, if you see this, right? So if I uh, start taking the orders in the digital form, it is also important that my production system should also be flexible, right? So if the customers can actually um, uh, announce or declare that this is the product they want, right? My production system should also match with that thing, right? And that is where the economies of complementarities come in. So this becomes more and more relevant as we become more platform dependent, right? We'll discuss these things. Now, so now we come to so we have seen different eras of production, right? So we have talked about production, mass customization, and the things which become more and more relevant in recent past is mass personalization, right? And we need the right business models for it. So when I say business models, it is how you deliver the value to the customers, right? So we'll formally define it in next one or two slides. But for time being, just take it that it is about how you deliver the value to the customer. Okay. Now, there is a very interesting paper produced by, written by Levitt, titled Marketing Myopia, published in HBR. And this paper, I think if you have taken any marketing course, it may be part of that course, right? And it says the companies were too focused on products and not enough on the customer needs, right? So, so companies focus too much on the products. They are not very specific about the customer requirements. And just to extend this argument, so this is taken from a recent book by Peter Marsh, uh, The New Industrial Revolution. While engineers tend to be more interested in how products are made, what really counts is how they are used. Right. So I think I'm just extending this argument by Levitt. In fact, in one of the papers, he mentioned that the companies do not buy drilling machines; they buy holes, right? And I have seen something very similar when I visited some company in Bangalore. So I think they mentioned to me that some of the aircraft manufacturers are actually converting to that kind of a business model. So they actually outsource the whole drilling operation. So they are no longer interested in buying the machines, right? And the technology of IoT, maybe we'll have a discussion on that. The technology of maybe industrial IoT allows us to track how many holes or drill has been done, what was the thirst, the rotation, everything is captured, right? So you actually pay for how many things or how many holes have been properly drilled, right? So all these business models are actually coming up. So I think the next slide will give you some more insights on what I'm saying. So this is a very interesting concept given by one the founder of Acer, the smiling curve in 1992. May not be true for all the products, but if you see this, this is the production chain right from the concept to the sales and after service. And what it actually says, the most value addition comes from the sales and the after service, correct? Right. So it means that that if we actually can monetize this part by some means, that actually can make firm successful, right? So manufacturing, the value addition may not be much, right? So in fact, these days we are talking about concept called as servitization. In fact, some companies are actually talking about can we make manufacturing as a service, right? So because the value addition comes mainly from the sales and the after service. Right. So this takes us to um the definition of business models. So a business model defines the way a firm creates, delivers, and captures the value. Right. So the classical example is always the razor blade. Right. So some companies, you may be aware that they actually sell the razor at a pretty low price, but the blades may be very expensive. Right. So what it actually means is the most value addition actually come from after sales, right? So the more so this may not generate much value to the company, but this certainly would make it profitable, right? So the same extent, so I'm extending this argument again to three parts. One is designing it, one is manufacturing, and other is selling it, right? So I've taken it from a book on manufacturing by Coren, 2010. So there is a firm, and the firm has design, make, and sell operations, right? So all these three things are important, right? So you design the right product, you manufacture it with high quality, right? High speed, whatever that faster, cheaper part will still be applicable, and then you have the right business model to actually capture the value, right? So if you even if you have uh, any of these two things, third thing is also important, right? So even if you manufacture it well, you have the right product, but you actually don't know how to capture the value, you may not be a successful firm. Correct? Right. So I'll extend the logic. So if you see this, when we talk about the business models, I think one thing which becomes highly relevant is uh, what is the nature of technology available, right? So when we talk about manufacturing, we still are talking about the faster, the better, the cheaper, the diverse, right? I am adding sustainable from my side. So when I talk about sustainability, we are talking about sustainable manufacturing. And when I say sustainable manufacturing, in fact, a lot of groups across the globe, research groups are already talking about it. So there are groups which are titled like environmentally benign manufacturing, right? So the value you deliver is actually a function of technology, correct? So there would be societal needs which could indicate sustainable part. There could be market needs which could mean that the product should be diverse, right? And how you deliver the value is also a function of technology, right? So you can think of an example like if you have to take a taxi ride or if you have to go from A to B, uh, the technology maybe in 1950 may not allow you to use Ola or Uber kind of business models. Correct. Now the technology is available which can actually match the market needs to the manufacturing or to supply. Correct. So I'm giving the eyeglasses as an example because we are going to see that as an example in our subsequent slides, right? So this is the product, and in fact, we need this product in high variety because each customer may have a different requirement. But finally, what we want is this eyeglasses should meet the customer requirement, right? So the point here is, will there be technology which will do that, right? Can we think of additive manufacturing as a technology? Can we think of blockchain to make the supply chain more and more transparent? Can we have machine intelligence available on the on maybe a platform which allows us to forecast what is the market need? The production system is highly flexible, which comes as part of additive manufacturing. The supply chains are transparent. The things are well communicated to the suppliers. So all these things get integrated, and you would actually foresee a newer way of generating the value. All right. So I think as part of this course, we try to capture some of these ideas. Right. Yeah. So as I was mentioning about the example of um, um, the eyeglasses, right? So one of the largest manufacturer of eyeglasses is a company called Essilor, right? And so they make about, so I'm not sure whether this data is new, but I think the source which I've used, they mentioned about 320 million lenses in a year, say. And uh, you can actually say that they actually capture the customer demand, maybe in the digital form using some computers, which is 20,000, right? And you can actually see that there is pretty high variety. So 320 million lenses or different types of lenses they need to produce, right? Now, what they normally do is they don't keep all these things in inventory, right? So their inventory certainly will not have 320 million lenses. What they have is some kind of a blank, and that type would be about 400,000 types of blanks, and they manufacture these in 14 different plants. Now, when the customer demand comes, these blanks may be at these 330 labs, right? So these labs are closer to the customer, and these blanks will be converted to the required type of lenses at these labs, right? And this whole idea, so what you are actually doing is you are delaying the differentiation, correct? So 400 types of blanks are converted to different types of personalized products based on what the customer wants, right? So this is actually called as either the delayed differentiation or postponement, right? And what actually enables this thing? Maybe the technology, right? So you actually can maybe even the information technology which connects the customer to the product, right? Even the machining, which even the machining, even the machining which allows you to convert those blanks into the lenses, right? So this is called as postponement, and this is not something which is only applicable in the case of lenses. In fact, the former CEO of Essilor quotes that the data are fundamental to organizing 100 or more processes necessary to personalize blanks in a matter of hours, right? So, in fact, you can actually see the concept of variety, you can actually see the concept of speed, cost will always be there, right? And you want with sustainability, correct? And you also want maybe high quality, right? So all those things comes as part of this example, right? But as I mentioned, that is not the only example. There are other examples also. So when we talk about, say, modular products, right? Uh, it means that you manufacture the products in modular way, so the customization becomes easier. And what actually encourages this, because this law of manufacturing, that aggregation reduces variability. So you are looking for minimizing the internal variety without compromising the external variety, right? So three classical examples. So people who are aware of the Dell manufacturing. So in fact, Dell keeps. So these are called as vanilla boxes. This could be a vanilla computer configuration, right? So the customization happens when the demand comes. So LG is doing something similar. So what they have done is, so the refrigerator would be in a modular form. So based on your space requirement, they will customize it, right? So very interesting. So customer can actually get a very highly personalized product, right? Maybe very similar example is coming from the paint industry. So I'm putting Asian Paints, but I think it may be true for other paint manufacturers also, where you keep only the white as a stock, right? And this converts to different colors based on the customer. So there may be, you can even go to a paint shop and you can actually see that, right? So what you keep is only the white color. So even I think the vanilla ice cream could be the most common example. You keep only vanilla in stock and all the customization happens. And remember that the customer demand may be highly variable also, right? So it is important how you actually match the demand with the supply, and I think the technology plays a critical role, and that's why we are looking moving from an era of mass customization to mass personalization. In fact, one of the metric to capture this idea is what is the average revenue per product variant, right? And some of these companies actually have this number very small, right? Because they actually customize the product uh, based on the customer requirement, right? So it may happen that you actually have one product variant which is specific only to one customer, correct? So maybe I think the point here is the companies which may be successful are those companies which actually have low variation quotient. It means that average revenue per product variant is actually very small. Okay, right. Yeah, so this uh, is maybe captures the whole story what we have discussed till now. So we are talking about manufacturing paradigms coming from Koran, and I think right from the beginning of this course we talked about craft production, we talked about mass production, mass customization, mass personalization, and you can actually see the volume per variant and the variety, right? So when we were have craft, the volume per variant was small, but even the variety was high. When we go to mass, the volume because of economies of scale, right? The mass production, the volume per variant was high, but the variety was low. When we go to mass customer, so we are actually moving in this direction, right? And now we are in the era of mass personalization, where we want more and more personalized products, right? Yeah. So now the point here is, can we do better, right? Can we do further, right? Can we go further? Can we improve the manufacturing, right? So most of you may be aware of this definition of industry 1.0, 2.0, 3.0, 4.0, right? And we can actually say that there would be some general purpose technology which comes along with these different versions of industry, right? So the next is, or maybe ongoing is, what we say about the digital convergence, right? So this could become the general purpose technology, and all the other technologies may merge with it, right? So uh, so one thing which becomes more and more critical, I think it is critical not just with the context of manufacturing, it may be for the much larger domain, even when we talk about reconfiguring supply chains. So it's not about automation. I think it is more about the communication. Product communicates with the machine to tell it exactly what to do, right? So machine knows that this particular product is coming, right? So when we talk about IoT or IIoT, that is something which we may be thinking of, right? When we talk about blockchains, I think we again may be thinking of something similar. So in this case, the communication is not actually just between machine to machine. It may be also between the product to machine, right? So that is something which comes as part of digital convergence, and this could go beyond mass personalization, right? So I think this gives you some idea about, in fact, this may not be the complete list. Some of the countries actually have come up with their own national initiatives, right? You can see example of US, so they have the AMP 1 and 2, Make in India, intelligent manufacturing in China, e-factory in Japan, industry, in fact, the word industry 4.0 came from Germany, right? So these are different national initiatives which are trying to actually look beyond this mass personalization and how the modern digital technology can be integrated with manufacturing, right? Yeah, so I think this gives you some flavor of uh, the different technologies. I think so. In this course, we may not be talking about all the technologies, right? But we may be talking about parts of machine intelligence, blockchain, additive manufacturing. I think we'll have a substantial because Dr. Chandrasekhar from Wipro would emphasizing only on additive manufacturing, right? We will have some discussion on IoT, digital supply chains, platforms, cloud manufacturing, right? So I think we'll just take small parts of all these technologies and try to just explain how they are actually influencing the manufacturing, right? So this may be the important part of this course. Right. So I just give you one example of Siemens smart factory in Hamburg in Germany, where they actually produce this PLCs, the programmable logical controllers, right? And this may be the larger ecosystem. I give you some numbers to give you the insights. So let me skip this part. Uh, yeah, so this actually talks about efficiency, agility, risk capturing, and innovation, right? So let me not spend time on this. Let me directly come to what the Siemens is doing, right? Uh, so you can actually see this in manufacturing and process. People are running their plants deterministically. So the processes are well understood, right? This is something very stable, static, and the it has advantage that it is very robust, right? But what it actually does, it actually removes the flexibility, right? So you remove defects because of robustness, because of stability, but the flexibility is not there, right? So when we talk about digital factory, it also provides the tracking as well as the flexibility. So I give you some numbers about you can actually see 12 million units per year, 1 unit per second. This is the number coming from the digital factory. So very high defect-free production. The output has gone up, and you can actually see the statement about the digital convergence, what I made earlier, that the products control their own manufacturing processes, right? So McKinsey estimates that the operational efficiencies in factories has the potential of adding about $3.7 trillion by 2025, right? So this gives you the context. This gives you the number, what numbers we are actually talking about, right? So with this, I will stop um, my part for time being. The next session, we have an invited speaker, Mr. Murli, who would actually talk about the manufacturing radar, right? So he will actually give you how these technologies are impacting the manufacturing, correct? After the manufacturing radar, he will continue his sessions on agility, on manufacturing agility, right? After that, I'll actually come back and talk about these technologies, right? So for next maybe 4 sessions, you will be listening to Mr. Murli, right? Thank you.